Welcome back. After exploring thunderstorms, it's time to focus on something that affects every single flight: visibility. Whether you're flying VFR or IFR, visibility can make or break your ability to operate safely. In this episode, we'll cover how it's defined, what impacts it, and why it matters. So, what is visibility? In aviation, it's the distance you can see and identify prominent objects under current conditions. It's usually measured in statute miles, meters, or kilometers, depending on the region. There are three key types of visibility you need to know. Flight visibility, what the pilot sees in flight. Ground visibility, what ATC sees from the tower. Runway visual range, RVR, the distance visible down the runway centerline, often reported in meters. RVR is especially important for low visibility approaches and landings. It's calculated using runway sensors and is specific to the approach end of the active runway. It often differs from the general visibility reported in METARs. Let's talk about how visibility is reported. In METARs, visibility is shown right after the wind information. For example, this means visibility is 6,000 meters, with mist present. If visibility is 10 kilometers or more, many METARs simply report 9,999, meaning no significant restriction. But below that, precise values help pilots understand how far they can see, especially on approach. Common causes of reduced visibility include fog, mist, haze, smoke, dust. Precipitation. Each behaves differently, and pilots must recognize which is which to plan correctly. Let's break them down. Fog, FG, forms when the air temperature drops to the dew point. Visibility is usually less than 1,000 meters, and it's classified by density. Light fog equals visibility 600, 999 m. Dense fog equals less than 600 m. Fog is a major hazard for both takeoff and landing. Mist, BR, is less dense than fog. Visibility between 1,000 and 5,000 meters. It often forms in humid conditions and can hang around during early morning or evening hours. Haze, HZ, is caused by dust or pollution in dry air. It reduces visibility and creates a yellowish or brownish tint to the sky. Unlike fog, haze isn't moisture-based, it's dry and persistent. Smoke, FU, and volcanic ash, VA, are also visibility reducers and dangerous ones. Smoke can lower visibility drastically near wildfires, while volcanic ash can cause engine failure, abrasion, and instrument malfunctions. Then there's blowing dust, DU, blowing sand, SA, and blowing snow, BLSN, all of which reduce visibility by lifting particles into the air. These are common in desert, Arctic, and mountainous regions. Let's not forget precipitation. Rain, RA, can reduce visibility quickly, especially heavy rain. Snow, SN, reflects light and causes whiteout. Drizzle, DZ, is gentle but often signals low ceilings and fog nearby. All must be considered when assessing arrival conditions. Slant visibility is also important. That's how far you can see ahead and below on final approach. Even if METARs show good surface visibility, slant visibility might be poor in fog or haze layers. During descent, pilots need to spot runway lights, PAPIs, or visual references early enough to transition from instrument to visual. If visibility doesn't allow that, you go around. Let's look at VFR minimums. In most controlled airspace, you need 5 kilometers visibility, 1,500 meters horizontal distance from cloud, 1,000 feet vertical separation. If conditions drop below that, VFR becomes illegal and unsafe. For IFR, visibility impacts approach selection. Each approach has a minimum visibility requirement. For example, ILS Cat I needs 550 m RVR. Cat 2 requires 300 m. Cat 3 can be as low as 75 m with proper equipment. Let's review a real case: URI flying into a foggy airport. METAR reports 300 m FG OVC 002. You're equipped for Cat 3, but a power outage knocks out the ILS. Now you need a new plan. Always have alternates when visibility is low. To prepare, pilots use tools like METARs and TAFs. ATIS broadcasts. Automated weather stations. RVR sensors and sometimes even pilot reports to confirm actual visibility in the area. Keep in mind, visibility can change quickly. Fog may roll in within minutes. A sudden rain shower can drop vis from 10 km to 2 km instantly. Stay flexible and monitor continuously during approach and departure phases. Let's recap what we covered today. Visibility is measured in meters or miles and affects every flight. Fog, mist, haze, smoke, and precipitation reduce visibility in different ways. Slant visibility matters as much as horizontal. Know your VFR and IFR limits. Always check RVR and alternate options before committing to land. In the next episode, we'll continue with visibility, Part 2, where we'll dive into obscuration codes, ATC considerations, and tips for navigating reduced visibility situations with confidence. See you in Meteorology number 34, Visibility, Part 2.